Welcome to this week's feature of the week on linear interpolation of regressors in Monolix. In previous versions of Monolix, the only option for how regressors were interpolated was last value carried forward. However, new in the 2024 version, there's a second option, linear interpolation. In both cases, the interpolated value is used to interpolate both missing values in the dataset, those with a dot as the regressor value, as well as to obtain values between time points defined in the dataset. For a model with an analytical solution, we only need the value at the time of the observations, so the interpolation method doesn't matter. The impact is only cosmetic when plotting the prediction on a fine grid like the individual fits. But for a model using the ODE solver, the regressor value at any time point is required, and here the interpolation method matters. Let's take a look at how these two methods differ. Here we have an example of using last value carried forward with a trial with crossover design with different doses administered in the same individual about a month apart. The individual is weighed at the time of each dose. In this case, we can assume the weight is relatively stable over the short term and would only want to update it in the longer term for a new period. An advantage of last value carried forward is that if you're using a model with an analytic solution, the model will be solved with a piecewise analytical solution. This is a new feature in Monolix 2024. Linear interpolation, on the other hand, smoothly interpolates between 2 points. Here I have an example of using concentration as a regressor. We are not explicitly modeling the PK part, we only want to model the PD part. The plot shows concentration versus time, and shown in red is last value carried forward interpolation, which would not lead to good results. Shown in blue is linear interpolation, which better represents what we would want to use for concentration in the PD model, especially the time from the start to the peak, where we expect an increasing value, not zero carried forward. If interpolation is needed before the first point or after the last point, the value of the first or last point is used. So let's look at an example of how to implement linear interpolation in Monolix. I browse to my data file and load it, and most of the columns are automatically tagged except for the last column, the CC column, which that's my concentration, which I'm going to tag as a regressor. Once I do that, the regressor settings appear here under data information. I can pick between last carry forward and linear interpolation. So I'm going to pick linear interpolation and then click accept. Before doing the structural model, let's go take a look at plots. Here is the PD data versus time, but another nice new feature is displaying the regressor on the x-axis. Under settings and axes, I can pick to display the regressor. If I have multiple regressors, I can pick which one to display. This allows me to show the response versus concentration if I want to look for things like a lag effect. Now let's go to the structural model, where I can pick my model file. Here I have CC, which is used in my turnover model for the response, defined as using a regressor. In this case, it's going to match the column because they're both named the same. But if I do have multiple regressors and I'm not using the exact same name, I do have to be careful to define them in order. After running the model, I get a reasonable initial fit to my data, which I can further refine. You can see that if I hadn't used linear interpolation, the model fit is not good due to inappropriate interpolation method, and especially the early part is poorly fit with zero carried forward. I will point out that the same regressor interpolation choices are also available in Simulx for projects that use regressors. In summary, Monolix Suite 2024 now offers linear interpolation for regressors in addition to last value carry forward, which is more appropriate in some cases, like using concentration as a regressor for a PD model. Thank you for watching and have a great week.